What's going on, everybody, and welcome to day 8 of our Juniper Networking series. In today's video, we are going to be talking about rapid spanning tree protocol. So when switches are powered on to the network and they come up, they are going to exchange what we call BPDUs. And within this video, the field that we're going to be manipulating is the bridge priority field within BPDUs. And then there's another field that we're going to be looking at within this video as well, and that is the MAC address. So when switches are powered on, they exchange BPDUs on layer 2 ports. And that is basically how the switches communicate with each other to determine which switch is going to be the root bridge. So the first field that is evaluated within the BPDU is the bridge priority. So whichever switch has the lower bridge priority is going to be the switch that is elected as the root bridge. Now, if the bridge priorities are the same value, the next field that is going to be looked at is the MAC address. So whichever switch has the lower MAC address is going to be elected as the root bridge. So within this video right here, I am going to be manipulating the bridge priority field within the BPDUs. And then as a result, we're going to see one switch be elected over the other switch. So as we know, at layer 3, we have fields to prevent loops from occurring within our network. At layer 3, the IP layer, we have the TTL field within our packets. So our TTL field is decremented at each hop that it goes to, each router that it touches. And if that field gets to a value of 0, then our packet is dropped. It is no longer being forwarded within our network because that TTL field has went to a value of 0. So at layer 3, we have a loop prevention mechanism. But at layer 2, within our frame level, we do not have a loop prevention mechanism. So technologies such as rapid spanning tree were developed at layer 2 to prevent physical loops. So if we physically connect all 3 of these switches together in a loop, we have technologies such as rapid spanning tree that is going to block certain ports from being in the forwarding state to allow loops to be prevented at the layer 2 level of our networks. So sometimes we connect our switches together within a physical loop and have spanning tree block certain ports for redundancy purposes. So if one of our physical links goes down, spanning tree has capabilities to detect that a link has went down. It'll recalculate the topology, bring certain ports back up, but still prevent loops from occurring within our layer 2 network. As we know, broadcast storms can bring down our network within seconds. So we need technology such as rapid spanning tree to be implemented within our layer 2 networks to prevent loops from occurring. So without further ado, let's hop into our lab and manipulate our bridge priority field to allow one switch to be elected as the root bridge over another switch. All right, so we are logged into the top switch. So we only have these bottom 2 switches on right now, which is the 48 port switches. This top one, the 24 port switch, is not currently powered on. So between these 2, we're going to see which one is elected as the root bridge. So right now we're plugged into the top one. So let's just do a show spanning tree bridge, just to see the basic spanning tree information on this switch. So right now we can definitely tell that this switch, the top switch, is not elected as the root bridge. And the reason we can tell that is because the root ID right here, if we look at the MAC address, this is different from the local parameters that is configured on this switch. So this is the bridge priority and MAC address of this top switch right here. So it has a priority of 32,768, which is the default, and it has a MAC address of 64649B, etc. Now the root bridge that was elected for this switch, we can see its bridge priority, which is 32,768, but it was elected as the root bridge because its MAC address is lower. As you can see, it starts with 40:71. :83, etc. So 40 is less than 64. So because of that, this bottom switch was elected as the root bridge. So let's connect it to the bottom switch and do the same command and see if there is any difference. All right, we are connected into the bottom switch. Let's log in. All right, let's do a show spanning tree bridge. And we can see that the root ID and the local parameters are the same on this switch. So that is how we know that this bottom switch was elected as the root bridge. Okay, so now what we're going to do is I am going to change the priority of the top switch to a value lower than 32,768. I'm going to restart both switches, and we're going to see if the top switch is elected as the root bridge. So right now, the root bridge is Ben's AS500. When we restart these switches and I put the bridge priority to a lower value on the Ben AS600 switch, it should be elected as the root bridge. So now let's first reconnect into the top switch and change the bridge priority. All right, so let's do an edit. And let's do a set protocols. We want to do rapid spanning tree, so RSTP. We want to do the bridge priority, and we need to do it in increments of 4,096. So I'm going to do a bridge priority of 12,288. Okay, let's hit enter there. Let's do a commit and quit. And I have some BGP and OSPF remnants from other labs that I was testing out, so don't worry about that. But this commit was successful, so now let's go ahead and do a request system reboot at now, and let's hit that. Let's do yes, and let's plug back into the bottom switch and do a reboot as well. All right, let's do a request system reboot at now. All right, now we're going to wait for both switches to reboot, and then we should see that the AS or Ben switch AS600 is elected as the root bridge because it's going to have a lower priority. All right, so both switches are online. I just logged into the AS500 switch. I wanted to give these switches a minute to fully boot and allow the BPDUs to be exchanged and allow the topology to be understood at a layer 2 level. So hopefully it has been enough time. Let's do a show spanning tree bridge. Okay. And it looks like the topology has been figured out. So now we can see that the AS500 switch is not the root bridge. And we can tell that because the root ID for this switch is different from the local switch parameters. So the local switch's parameters is the 40 MAC address, and if we remember from previously, this was the MAC address that was selected because both of the priorities was the same. But since we lowered the priority on the AS600 switch, it has now been elected as the root bridge. So now let's go ahead and switch the console cable back to the top switch. And now this switch should now be the root bridge. So let's log in. All right, let's do a CLI. Let's do a show spanning tree bridge. And yes, as we can see now, the AS600 switch is now the root bridge. We can tell because the root ID and also the local parameters bridge ID is the same. So now what I'm going to do is I'm going to power up this third switch, and we're going to connect our switches within a layer 1 loop, and then we're going to see rapid spanning tree in action. We're going to see it blocking certain ports, and we're going to configure this top switch as the root bridge by lowering its priority even lower than the 12,288. So let's get this switch powered up, get it connected up, and do these configuration changes. All right, so I powered up this top switch. Let's go ahead and log in. All right, so let's go ahead and change our bridge priority to a value of 4,096, which is going to be lower than the 12,288. And then because of that, when we reboot all of these devices, this top switch will be elected as the root bridge because it's going to have the lowest bridge priority. So let's do a edit, and let's do a set protocols, rapid spanning tree, so RSTP, bridge priority. Let's set it to 4096. All right, and let's do a commit and quit. So that commit was successful. So let's go ahead and do a request system reboot at now. Let's do a yes. Let's do a request system reboot at now. Request system reboot at now. Now I'm going to connect these switches together within a loop and then wait for all of them to reboot. And then we're going to see rapid spanning tree in action with it blocking certain ports. We're going to see which ports are forwarding. And then we're going to see that this top switch is going to be elected as the root bridge because we configured it to have the lowest bridge priority. Alright, so all of the switches are booted. I want to kind of give them a minute to allow each switch to exchange the BPDUs so the root bridge can be elected. I am plugged into the top switch, so we're going to start with that one first. So let's log in. Okay, let's do a CLI. And let's do a show spanning tree bridge. And hopefully, yep. So this is the root bridge because the root ID and also the local parameters are the same, and it has the bridge priority of 4096, which is what we configured on this top switch. All right, so both of its ports should be designated. So if I do a show spanning tree interface, yep, so its port is forwarding and it's designated. Okay, so let's plug into this second switch now to see what its interfaces are looking like and what its bridge ID and also its root ID is. All right, let's log in. All right, let's do a show spanning tree bridge. And we can see that its bridge ID reflects what was the top switch, which is the root bridge. And we can see its local parameters. It has a bridge priority of 12,288. And we can see its MAC address right here. So if I do a show spanning tree interface over here, we can see that it has a root port and it also has a designated port. Alright, so its root port is best path back to the root bridge is gigabit 000, and its designated port is a GE10. Alright, so now let's plug it to the bottom switch, see its bridge parameters as well as its interface parameters. Let's log in as root. Type in our password. Let's do a CLI. Let's do a show spanning tree bridge. And we can see its root ID is the same as the top switch because this is our root bridge. We can see its local parameter. So the bottom switch's local parameter, it has a bridge priority of the default, which is 32,768, and we can see its MAC address right here. So if I do a show spanning tree interface, we can see that its gigabit 10 is blocking, and that is to prevent a layer 2 loop from occurring within our network. And we can see its root port is the gigabit 0046. So that is rapid spanning tree in effect. It is blocking one of our ports to prevent a layer 2 loop from occurring within our network. So that is a lab on how to manipulate rapid spanning tree within different switches. And I hope you guys enjoyed day 8. Hope to see you in day 9. Until then, peace out.